Okay, here we are again. All right, so can y'all hear me okay?
Yeah.
All right, good. Okay. So we'll give it a few minutes just to see if get a few more people in here. So this one I evidently haven't been in yours. Okay, so this is the way to go into it, the learn. See, if you try to go in through assignments, like anything that's in the past, see,
Yeah, and I've been going into that.
well, it does let me go to it. It does let me go to it. I know that some way that students tell me they try to go in and it's not letting them. But this is the way you always are sure to get where you need to go is go to learn.
Okay.
Go to learn. If you go to learn, it puts you in the right spot. See, I hadn't been in this one in a long time, so I never did do some of chapter 2. So I'm going to have to do it. But as soon as I do one or so of them, it's going to put me back on track so that I'm not late with the other stuff. Because you don't want to be working too much on this. But Alex is smart enough to realize how to pace you to do it. So you're never missing anything because you missed any, dates or anything. It'll never let you get out of missing something.
Okay.
So just always make sure and go through learn. And if you do that, because I have students, they go through Canvas and try to do that. And I know that is where maybe that's where you see it where it says it's locked. But I do know that you get that because I've seen it.
I go through Alex.
Yeah, always go through Alex. If you go through Alex, then you don't run into any problems with keeping up with those things.
And even if you go into Canvas, and if you haven't done the work, it's gonna open up in Alex anyway.
Yeah, like I said, I don't ever go through I don't ever go through Canvas because I just don't trust it as far as the syncing is concerned, and that's why I'm going through all this where I'm redoing everything because to make sure that those grades are over there properly because I just don't trust it. It's supposed to, but it takes its time sometimes.
I do all my work at Alex, and Alex, it takes his time to sync with Canvas.
Yeah, it takes its time. For one thing, a due date has to pass before it even attempts to sync. And then it may take a couple of days. And then sometimes it'll sync improperly or don't say improperly. It'll not sync certain people, like it couldn't find the grades or something like that. So I have to go back and clear it out and resync it. Okay. But eventually it gets everything in there because I double check them before. I'm not going to let y'all, because for the most part, it's the midterm and the final that determine, and that's just to recap all this. That's the things that count for the most, the midterm and the final. All right. The other things are icing on the cake. All right. So let's Look at 10.4. All right, so this is just dealing with sample spaces and how they can help us calculate probabilities. Now, the sample space is essentially just how many possible outcomes that can happen when we perform an experiment. So this right here is a visual of 2 die now. When we were first started looking at probability, we were just looking at 1 die mainly. But if you got 6 possibles for 1 die, they got it as red, and 6 for the other die, which is green, then 6 so 6 up here, 6 here. So 6 times 6 is equal to 36. And so you can kind of just go through here and see you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and keep on counting 13, 14, 15, 16, 17, 18, 24, 24, 25, 26, 27, 28, 29, 30, and then 31, 32, 33, 34, 35, 36. 36 outcomes for this. And you see how we get it numerically, which in 10.5, we're just going to look at the numbers. We won't really be looking at the visuals anymore. Then we know that there's 36 different possibilities when we roll that die. 36 different possibilities. 6 times 6. All right, so let's look at these like numerically. This is the same sample space for the 2 die, see 1 through 6, 1 through 6. And then I've got them listed out as numbers rather than as looking at the actual die. Now, let's say we want to answer this question here. Find the probability of getting a sum of 9. What does sum of 9 mean? What is that word right there?
Addition.
What does that word mean?
Addition. Total.
Yeah, they add up to 9. Good, good. They add up to 9. All right. So let's just kind of go through here. What do these add up to?
2,
2.
3.
1 and 2 add up to 3. 1 and 3 add up to 4. 1 and 4 add up to 5.
I counted 3 of them.
6, 7. So none on the first row add up to 9. Let's go back over here. Now these start off a little bit higher. There's 3. 2 plus 1 is 3. 2 plus 2 is 4. 2 plus 3 is 5. 2 plus 4 is 6. 2 plus 5 is 7. 2 plus 6 is 8. All right, so you see those blue numbers up there?
Mm-hmm.
Those are the sums of each one of those numbers. So here we got 4. Here we got 5, 6, 7, 8, 9. We finally got a 9. All right, so there's one of them right there. Think there's any more?
Yes. 2.
5, 6, 7, 8,
3 more, I meant.
9, 10. So this one sums to 9. Okay. 6, 7, 8, 9. It's a funny looking 9, but let's see if I can fix it. Because that's one of the ones we want. So this is 10 and 11. And then down here, let's see, 7, 8, 9, 10. Well, okay. So now here's another 9 here and another 9 there. So what does that give us? That gives us number of 9, some 9s, number total. Okay. So we're going to make our little fraction. So this is going to be so how many did we say there were? 4, right?
4, yeah.
And then how many outcomes did we say there were? 6 times 6?
36.
All right. And then we're going to simplify that from here on out. You got to make sure your fractions are simplified. 4 goes into 36
9
9
times.
times
9 times.
and into itself once. So this is 1/9. So there is our simplified probability. All right. Any questions about that? Let's go down here and get another one. I'm going to bring it back up here so I can, we can use the same numbers. So that was A. So let's put B right here. Find the probability of getting a sum that is an even number. All right. How many even numbers are there? If we don't know, we've already got the sums in here. We can go in and check them. That's even, right?
Yep.
Let's take out all these check marks and put new ones. So the even ones now are
2, 4, 6, 8, 10, 12.
this one, 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 this one,
Yeah, no,
this
2,
one, and that one. So how many is that?
3, 6. 6, 3 times 6, 18.
Yeah, it's 18. And remember, there's 36 total.
Reduce it.
And so that ends up being 18 goes into there one time, twice. And you can kind of see that because probability is the same thing as proportion. You might be able to see that half of those are checked. Half of them have a green check. So we
Mr. Cruz,
verify both ways. Mm-hmm.
do ever the probability be improper fraction?
No.
No. Okay.
Probability always has to be a plain old fraction. It can be 1, which technically is improper fraction,
What about
or it
10
can be
over 4?
0. No. It can never be greater than 1. Probability will never be greater than 1.
Got you.
Probability is always positive, so it's got to be 0 or more. And it's going to be greater than 0 and less than or equal to 1. All right, so let's see if we can get us another question.
So can you find one where it's talking about rolling the dice and flipping it?
Yeah, we'll hit that kind of next.
Yeah, that one.
After we finish this.
All right.
And we'll draw out a tree. Well, I already got tree drawing out, but yeah. We'll hit that next. All right. So we want to find the probability of rolling two numbers whose sum is greater than 8. So I'm going to come back now and you help me check the ones that are greater than 8. All right. So greater than 8. Greater than 8. Let's see. Make this a different color here, like red. Greater than 8. So right here.
9 over 36.
These are all the ones that are 8, right?
Mm-hmm.
6, 2, 5, 3, 4, 4, 3, 5, 2, 6. Maybe I'll try this instead.
Count of 9. 9 over 36.
So the red right there encapsulates all the ones that are 8. So now, which ones then would be greater than 8? 9 is greater than 8. 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 10 is greater than 8. 10 is greater than 8. 11 is greater than 8. 11 is greater than 8. And the highest one will be 6 plus 6, which is 12. All of those have a sum greater than 8, correct?
Yeah, I miscounted. 2, 4, 6, 8, 10.
All right. So how many is that over 36?
10.
And the reason why the probability is never going to be greater than 1 is because, see, the large number is always down here. The larger number has to be down here. Okay. That's the total number of outcomes. That's always the denominator. So that's why that fraction never ends up being greater than 1.
Gotcha.
So how many were there?
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Good. And so this comes out to 10 is divisible by 2. 10 into 2 goes 5 times. And 10 into 36 goes 18 times. And so there's our probability for some greater than 8. Any questions about how I'm calculating the probability? Just to recap, the denominator for all of these A, B, and C, which were based upon the die, for the denominator was all 36. Okay.
All right.
And then the numerator is however many that fit this criteria here. See, some greater than 8. Some is an even number. And up here, it was sum of 9. So with that, that's a subset. That numerator is a subset of the denominator. So again, that illustrates why it will always be a regular old fraction, never greater than 1. And of course, never negative. All right, so let's get rid of all this and go on to another one. I got one now, I believe that that's like you were talking about the tree. All right, here is a tree diagram for 3 children. In other words, first child, second child, third child. So then the possible outcomes here are boy, girl for the first child, right?
Mm-hmm.
About this. Then after you have, let's say, a boy, then you have the second child, boy or girl again. Then branching off of that boy, and so if you got 2 boys in a row, you can still have another boy or you can have a girl. So once you have that first boy, you could have a girl for the second girl, and then you can have boy or girl there as well. And that's what these are here. Boy, 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 girl, boy, girl, boy, boy, girl, girl. Then we come back down here, and all the first children are girl. Well, after that, you can have boy, girl. If you have a boy, then you can have boy, girl. If you had a girl for the second one, then you can have boy, girl. So then all of these are the outcomes that we can have. Boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. All right, so let's see if I can put everything on one page here. All right, so let's take all that out. All right, so find the probability of having a family with at least 2 girls. First of all, how many outcomes are there? There's 2 outcomes here, 2 outcomes here, 2 outcomes here, 2 times 2 times 2 is
8.
8 outcomes. 8 outcomes. So that's the outcomes right there. 8 of them. All right. So that's going to be our denominator for all of these. All right. So the probability of at least 2 girls. Now, what we got to do now is count the ones with at least 2 girls. So first of all, we want to get straight in our head up here. What does at least 2 mean? Does this one here have at least 2 girls in it? Boy, 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 or is there at least 2 girls in there? That's no 2 girls in there. There's not even 1 girl. How about this one right here? Has that got at least 2 girls? That's just 1 girl. That's not at least 2. Same thing here. That's 1 girl. Boy, 2 boys, 1 girl. Now, here is where we run across the first one. There's 2 girls. That's at least 2. Okay. At least 2 means 2, or in this case, it would also include 3. Because we only have 3 kids. So not this one. That's just 1. But here we got at least 2. And here we got at least 2. And here we got at least 2. That's 3. That's at least 2. If it costs at least $2 to get in, if you donate $3, you're still getting in because it's at least 2. All right, so here our denominator is going to be 8. And then there's 4. Make it better 4.
1/2.
And then 4 goes into 8 twice. So this is 1/2. And again, because proportion and probability are the same thing, you can see that exactly half of them are checked. See, there's 4 more over here that weren't checked, the ones with the blue line. So that's 1/2. All right, find the probability of having all children of the same gender. What does that mean? Same gender.
Same. All boys, all
Or
girls.
is boy, boy, boy all the same gender?
Yeah.
Yeah. Boy, boy, girl, well, that's got 2 genders. Boy, girl, boy's got 2 genders. Boy, girl, girl's got 2. Girl, boy, boy's got 2. All of these have 2. The only other one that has all the same is the girl, girl, girl. All right. So then that translates as 2 over 8. And that's 1/4. All right. 1/4 of them are all the same gender. See if I can get this last one. So there's that. Bring the last one up. All right. Find the probability of having a family with exactly 2 girls. All right. Does boy, boy, boy have exactly 2 girls?
No.
No. Does boy, boy, girl have exactly 2 girls? No. Boy, girl, boys only got 1 girl. But here we got boy, girl, girl. That's exactly 2 girls. Girl, boy, boy is exactly 2 boys, but not 2 girls. But here again, girl, boy, girl has exactly 2 girls. And so also does girl, girl, boy. This is not exactly 2 girls. That's exactly 3 girls. It was part of at least 2 girls, but it's not the same thing as exactly 2 girls. Okay. So now over 8 is 3. And this one is not simplifiable because 3 does not divide into 8 evenly. So this one will stay right there. All right. Any questions about that? All right. Let's go on to another one. All right. So now we got a little bit different sample space. This is cards. And they've got them all written out now here. The reason why we're writing all these out is just so we can get the hang of where this is coming from. The total is the denominator, and then we look for specific ones for the numerator. All right, so
What we doing?
let's look at So how many cards are there in the deck? Because what we're going to do is we're
13.
going to take this deck of cards and we're going to pull one of them out blindly. You know, somebody's going to shuffle the deck and hand them and say, here, pick a card, any card. All right. So how many cards are there?
52.
Yeah, there's 13 here, 13, which is 26, 39, 52. 52 total sample space. Okay. So that's going to be the denominator for all of these to start out with. We can simplify it. All right. So here, how many aces are there? The probability of an ace.
4.
There's the aces right there. Sort of like a 1. It's just for card games. It's kind of does double duty. It can be a high card or a low card. So there's 4 of those. Over 52. And then we can simplify that. 4 goes into 32, 13. I'm sorry, 52, 13 times.
Oh, 4 by 52. The 52 look like a 3.
Yeah, I know.
I was saying 32. Okay,
Yeah, I'll fix that.
that's all right. Face cards.
All right. So now we can also see that in every one of the 13, so there's 13 clubs. For every one of those 13 clubs, there's 1 ace. For every one of the 13 hearts, there's 1 heart ace. For every one of the spades, there's 1 ace. For the diamonds, there's 1 ace. So the proportion that we're getting when we simplify that is like looking at 1 row, because this is just 4 times 1 row. Okay. How about a face card?
12. King, queen, and king. I mean, jack, queen, and king 4 times. 3 times.
So here's the 4th.
Yeah,
There's 12 of those, right?
yeah, yeah. 12, 52.
I'm also trying to write small enough so I'm.
We're going to 52, 13 times.
And that's 3 out of 13.
Yep.
And you can see that. That 3 out of the 13 of the clubs is face cards. 3 out of the hearts are face cards. 3 out of the spades. Three out of the diamonds. So 3 routines. I'm going to write over here the clubs on the other side just so we have a little bit more room. All right. So how many clubs do we have here?
13.
There's 13. 13 clubs. So I'm going to put it over here. Over 52. And clubs make up how much of the deck? That's
1.5
quarter. The
or
black makes up 1/2.
Oh, 13 going for 2 full time. Okay. Right.
All right. 1/4 of the deck
1/4
are
is
clubs.
1/4 is 1/4.
1/4 of the deck is hearts. 1/4 of the deck is spades. 1/4 of the deck is diamonds. All right. So the next one, a 4 or a heart. Okay. So first of all, here's the hearts. Here's the 4s. And it does not say and, it says or. So the reason why we go over chapter 2 is to help us with these concepts of and or. because and means differently than or. So or means it can be either one. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13,
14,
14,
15,
15,
16.
16. See,
16.
I didn't count that one twice, and that's one reason why I'm checking them off. And
Yeah,
that goes back to chapter 2. And you remember you had that that was the little number of elements in the union of two sets, and union is or.
yeah,
You remember you subtract out anything that's in both, and fours overlaps with the hearts in that they both contain 1 4. So we don't count this one twice. So essentially we're 13 plus 4 is 17 minus the 1. Now I went ahead and just counted them to show you that, but that's where that chapter 2 stuff comes in. All right. So what did we say? We got 16
over 52.
over 52. So that would be 8 over 26 or 4/13. 4/13. Okay.
Mhm.
6 or 8 of spades. All right. So here's a 6 of spades. There's an 8 of spades. So what do we do for that? How many cards is that?
2 over 2 over
2 of
52. Yeah. That would have got me 2.
Yeah, it's kind of a little bit I'll just tell you this, because you're probably thinking, well, does it mean all of the 6s or an
Yeah,
8 of spades? If it had
yeah.
meant that, it would have done
And
that, put a comma there.
oh, okay, okay, gotcha.
Even though that's from the logic,
Mm-hmm.
while the parentheses and the
Mm-hmm.
commas line up. So
Yeah,
then this is 1.
and the true value. Yeah.
Yeah. See, all that stuff plays in here. So 126. So we got probability of an ace is 1/13. A face card 3/13. A club is 1/4. A 4 or a heart 4/13, and 6 or 8 of spades is 126. All right, let's go on down. I got some more here. All right, we should have enough time to do both of these. I may not do this one because this one is pretty much the same thing as the one with the 3 children.
Mm-hmm.
Head, tail, or boy, girl. Head, tail becomes boy, girl. So you end up having 8 outcomes. So we may skip that one for time's sake, but if we don't have enough time, I'll come back and we can go through it. But this one up here involves flipping a coin
Oh yeah, and the dice.
and then rolling a die. All right. So you're doing 2 different things here. You're going to flip a coin. If you get a head, then you roll your die. And then you got 6 outcomes. So you could have head 1, head tail 2, head 3, head 4, head 5, head 6. You could have your coin of tail 1, tail 2, tail 3, tail 4, tail 5, tail 6. All right. So how many outcomes is that?
12.
Yeah, it's 2 times 6 is equal to 12. So we got the denominator there real easily by just using that counting principle, the multiplication of the two different experiments that we're combining now. All right, so find the probability of getting a tail, then rolling an even number. Okay. So all of these up here are heads, so we don't want any of those because we don't want a head, we want a tail. So all the ones we're looking at are down here. And then we want an even number. So we don't want 1. We want 2. We don't want 3. We want 4. We don't want 5. We want 6. All right. So for this one,
3/6.
it's 3/12, right?
Right. Cause it's
But we
12.
can simplify that because 3 goes into 12 4 times and 3 goes into itself once. So you can kind of see also proportionally 3 out of 12 or 1/4 of those outcomes are t's that are even. Find the proportion of outcomes with an odd number. Odd number. Doesn't specify anything about head or tail. So it just says with an odd number. That's odd. That's odd. That's odd. That's odd. That's odd. And that's odd. So that ends up being how many? 6/12. Is 1/2. So here's our two probabilities.
I want to know if they're talking about the dice or the coon.
What?
That when they say find probability proportion of the outcome of the odd number. I also
You talking about the switch to the word proportion?
okay.
Is that what you're talking about? This is
Yeah,
probability.
like how would I know if they're talking about the dice?
Because those two things mean the same thing. Proportion and probability mean the same thing.
Okay.
Because you can kind of go back up here and see, like I said, with the deck of cards, that proportionally 1/2 of the deck is black, 1/2 is red. So that when we actually calculated the probabilities,
Okay.
you know, it comes out to be what we can see visually proportionally. So probability and proportion are the same thing.
Okay.
Let's see if I can do another one of these, and then we'll do the sandwich problem for last. Let's see if I can come up with one more. Find the probability of there's not a whole lot of choices here. I guess that's why I only had 2. Find the probability of head and odd. So head and odd, very similar to the one we did with tail and even. There's 3 of those. So for this, there's going to be 3 over 12, which is also 1/4. Okay.
Okay.
So very much like A. That's why I only had 2 of these, but I wanted to give us a little bit of time. This is one of my favorite ones here. This one about it's sandwiches. If you ever been to, I'm sure everybody's been to these things where you got like a catered. I mean, you can go to Rouse's and get them, or Walmart, and you get 100 party sandwiches. And usually this is how they make them up. All right. They have white or wheat bread. Now, white is wheat too, but usually they call it whole wheat. So that would be like the brown looking sandwiches. And then you got 3 different kinds of meat. You got ham, turkey, and chicken salad. And then cheese, cheddar, Swiss are the 2 cheeses. So what that gives us is 2 times the 3 meats times the 2 cheeses. So that ends up being 2 times 3 is 6 times 2. And that's also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 outcomes. So 12 is going to be the denominator for our question. So let's do this one. So I'm going to put it right here.
12.
So what is the probability of getting a ham sandwich?
12.
All right. So let's count. First of all, 12 is going to be the denominator.
Right.
All of these are going to have 12 as the denominator. Now, how many of these are ham? Now, let's see if I can. It's going to be hard for me to write it this small. But this would be W H C Let me try something real quick. Make this a little bit bigger. So that's 12 outcomes. So this is white, H, white ham, cheddar, white, ham, Swiss, and then down here, CB white,
So
turkey, cheddar, and white, turkey, Swiss. And you see there's kind of a little pattern here. Every 2, the meat is changing. And every other one, the cheese is the same. And then the first 6 are all the same kind of bread. So white chicken, cheddar, white
Chicken, cheddar, Swiss.
chicken, Swiss. And then these are going to repeat down here. So let's just put it, I'm not going to write out the whole thing, but all of these, in place of the W, I would have W for whole wheat. In other words, this is whole wheat kind of thing. Because they're both W, so all of these would be just WW for whole wheat. All right.
It'll be 8, 2, 4, 6, 8.
So now, how many of them have ham? Well,
8.
let's go down through here and count them. So 1, 2 are ham here. 1, 2 are ham here.
4.
So how many is that?
4. I'm gonna be getting tired. 4.
Yeah, we're almost done. It's hard to get mind going. Keep your mind going at 8 after 8 o'clock. So that's 4, because it would be this one, and this one, and down here, this one and this one would both be ham.
We'll reduce it.
4 over 12, which 1/3 of
1/3, yeah.
are ham. Go down and get another question.
Rice, where the probably get in a sandwich.
Mm-hmm. Yeah, so this one's going to be Swiss.
Swiss cheese.
All right. So let's go down through and check the ones that are Swiss. So this would be Swiss, 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 and this would be Swiss.
6 over.
So how many is that?
6.
What happened to my thing?
Okay, so there you go.
So it's going to be
6 over 12, 1.5.
6 over 12, right?
Mm-hmm.
And that's 1/2 of the sandwiches. Half of them are checked. All right. So with this one, I'm not going to have enough room. Let's go down here. What is the probability of getting a turkey cheddar?
Turkey cheddar.
So
2.
turkey. So it'd be WTC or WWTC, because that's the only two, right?
Right.
Because the cheddar ones.
Yeah, they say what type of bread, so I'll just say turkey.
So cheddar, turkey cheddar
And the whole wheat
would
turkey
be
cheddar.
this one
206,
and that one,
12.
which is 2 of them. Out of 12, which is 1/6. And then the last one, let's see, a probability of getting a wheat bread sandwich. In other words, the whole wheat.
Mm-hmm.
Probability of whole wheat would be any of the ones down here in this second half, see? all of these down here are the whole wheat ones. So that's 1, 2, 3, 4, 5, 6. Now, hopefully you kind of see there's a pattern here.
Yeah.
So the probability of I'm just going to put WW for whole wheat. Well, half of them are whole wheat. All right. All right. So, and I'll just kind of, again, point out the proportions to you. See, there's a pattern here. All right. And these patterns we're going to be able to use doing those counting methods, the combinations and the counting rule. Because let me point this out. With the bread, white and whole wheat, there's only two choices: half white, half whole wheat. For cheddar and Swiss, for the cheese type, there's only two choices: cheddar, Swiss, half cheddar, half Swiss. That's what we did over here on that one. And then for the meat, for a ham sandwich, see, it was 1/3 because 1 out of 3 meats is ham. All right, so that's enough for tonight. Have a good weekend. Try to get a little bit of rest, and then if you can get on your path, try to keep up with it, but get a little bit of rest and dive in next week, because we'll have before Easter, we'll be able to finish all this, and then after Easter, we got our next test.